Hello, you're welcome to my YouTube channel. Presenting the lesson, Patrick Divine, Tutor Patrick Divine. Okay, so today we are going to talk about chemical formula in chemistry. So today we are doing chemistry. We did mathematics. We are from doing trigonometry in mathematics, and we are doing chemistry today on chemical formula. Okay. So, if you're new to this YouTube channel, you can call me or you can WhatsApp me on this line. Okay, you can WhatsApp me on this line. My line is 0975 334778. If you are new to this YouTube channel, you can subscribe and share the link so that others should also benefit from this YouTube channel. Make sure you share the link, you subscribe, okay, so that whenever I do a lesson you should be notified. Okay, so if you want tuitions with me, I also do tuitions for the starting from grade 10 to grade 12, also for the first years who are in university. I also do tuitions in the sciences and mathematics. Okay, so I said this is my WhatsApp line. You can WhatsApp me on this one. This is my WhatsApp line, and I'll be able to help you. So today we are going to do chemical formula. Okay, so a lot of people find this topic to be difficult simply because they leave a lot of things behind. Okay, so before you do this topic, chemical formula, you need to know what a valence number is. Okay, so what is a valence number? What comes in your mind when you hear about a valence number? So a valence number, this is the number of electrons lost or gained or shared by an atom of element to attain a stable structure. It is the number of electrons lost, okay, lost or gained or shared by an atom of element to attain a stable structure. So we are saying that a valency number, okay, valence number is the number of electrons lost, okay, lost or gained or shared, should we say shared, okay, shared by an atom of element, okay, by an atom of element to attain, okay, attain a stable structure, a stable structure like this. So a valence number is the number of electrons lost, okay, lost or gained or shared by an atom of elements to attain a stable structure. This comes from bonding, all right? This comes from bonding. So whenever an atom has lost electrons, okay, has lost electrons, meaning that it gives, whenever an atom has given electrons, or gained, meaning that atom which has received or shared, sharing of electrons is between non-metals, okay, is between non-metals. Sharing of electrons is between non-metals, but losing and gaining of electrons is between metals and non-metals. Okay, so when it is the number of electrons that an atom of element loses, okay, when it loses, or gained. Also, it is that number, that same number which it loses, the number of electrons which it loses or gained or share, okay, by an atom of an element to attain a stable structure. To attain a stable structure, meaning that to be stable, meaning that it is full in its last shell. It is 8 electrons in its last shell, like these ones which are here. These ones here. Okay? So these ones here, they are stable. These are stable atoms. We call them noble gases. These ones which are here on your periodic table, they are noble gases. So their valence numbers is 0. They don't have valence numbers, this one. Okay, because they don't take part in bonding, they don't receive or gain electrons. Okay, so these ones, they don't receive or gain electrons because they are stable. All right, so you need to know what a valence number is before you do chemical formula. Are we together? So you need to know that metals always give electrons. Metals give electrons, eh? So you need to know that metals, so metals, they give or lose electrons. This you should know. So metals, they give or lose electrons. The non-metals receive, is it like this? Receive or gain, or share electrons, like that. So they receive, meaning that they receive from metals. Okay, they receive electrons from metals. So non-metals receive electrons from metals. They receive, the other term that you can use for receive is to gain, and they also share electrons among themselves. The non-metals share electrons among themselves. Okay, so if you are new to this YouTube channel, kindly subscribe and share. Okay, and suppose you want tuitions with me, online tuitions, you can contact me on this line. My WhatsApp line is this one, and also this one, you can call me, you can use the same line to call me direct. My number is +260 975 334778. Okay, 78, that is my line. Okay, so what do I mean by giving or receiving? Okay, what do I mean by receiving or giving electrons? So let's take it, for example, this atom here on your periodic table. If you check your periodic table, there are atoms here. Okay, so there are atoms here, and this periodic table. So when you look at your periodic table clearly, you see that they are metals and non-metals. So metals, where are they starting from? So the metals, they are starting from this side. Okay, this part, this side, going this side. Even these ones, they are metals like this. So when you reach here, all right, so when you reach here, okay, so when you reach here on your on this side here, this is group 3. So these are groups: group 1, group 2, group 3, group 4, 5 to 8. So when you reach here, so this is the demarcation of metals and non-metals. This is the demarcation between metals and non-metals. Make sure that you should know it is starting from boron here, like this. There is just a zigzag line like that. As simple as that. Okay, as simple as this. Chemistry is simple. Chemistry is simple. So the chemistry that they bring on the exam of the grade 12s, it starts from here. If you don't know how to balance an equation, if you don't know how to make a chemical formula, because you can't balance an equation without you knowing how to make a chemical formula of elements. Okay, so this is the demarcation between metals and non-metals, meaning that coming this side, these ones, they are metals. Okay, they are metals. Then these ones this side, they are non-metals, like that. Simple as that. So you should know starting from today that this is the demarcation of metals and non-metals. Okay, so it's like that. So I was saying that, so meaning I have this, I wanted to give an example of oxygen here. So we have oxygen. This is a what? A non-metal, since this is the demarcation here. So meaning that oxygen, it is a non-metal. Okay, oxygen has a mass number as well as a proton number. So this one is a mass number, this one is a proton number here. I'm sure you learned on this. Okay, this one is a mass number, this one is a proton number. Okay, so now how do we know the valence number of this atom? How do we know the valence number of this atom here? Okay, or should I say this element, oxygen, the element of oxygen. So oxygen, it is like this. This is oxygen, right? Then it has 16 as the mass number, it has 8 as the proton number. Okay, so you learned how to make an electronic configuration of an atom. So how do you make an electronic configuration of an atom? So this is it now. So this is the K energy level, the K energy level, L, M, and N, like that. K energy level, L energy level, M energy level, and N energy level. I'm sure you learned about this. So how do you do that? So meaning that this is the first shell, this is the second shell, third and fourth shell. This is just how to write the shells in an electronic configuration of an atom. These just show the shells. So you learned that the first shell, this is K. So the first shell, this is the first shell, second, third, fourth. So the first shell always become full or become stable with only 2 electrons. With only 2 electrons. So this is a proton number. And if you remember very well, you learned that a proton number is also equal to the electron number. Okay, the proton number is equal to the is equal to the number of electrons of an atom. So meaning that this is a proton number, meaning that, and the electrons are also what? 8. So we use the number of electrons to make the electronic configuration. Okay, so meaning that this one, it is full with what? With 2 electrons. Okay, so when we get 2 from 8, what are we going to have? So what is going to remain here? When you get 2 from 8, we're going to remain with 6, right? So and these, we should know that these other energy levels, these shells, these other shells, they are full with 8 electrons. Okay, they are full with 8 electrons, or they so I said that they need to be full with 8 electrons. Okay, 8 electrons, 8 electrons, 8 electrons. Since oxygen only has 8, okay, so mean that this one gets what? 2 electrons. Then this one, so when you subtract 2 from 8, you have what? 6. Okay, so you ask yourself, how many electrons left for this energy level to be full? Okay, for this energy level, the L energy level to be full, how many electrons left? I said this one, the first one, always is always gains 2 electrons, always has to be full with 2 electrons. The first shell. The second shell is full with 8 electrons. So if you see here, this is 6. How many left for it to be 8? 2 electrons left to be 8. Okay, so meaning that its valence number, the valence number for oxygen, it is 2. Okay, meaning that it needs 2 for it to be 8. Okay, it needs 2 for it to be a full shell. Okay, it needs 8 electrons for it to be a full shell. So if we draw a structure, we draw the structure of oxygen atom. So you draw it like this. So this is oxygen, right? So this is oxygen atom. This first shell, I said that it occupies what? 2 electrons, like that. Okay, it occupies 2 electrons if you did this in bonding. Then the second shell, so it has, so meaning that oxygen has 2 shells, this one and this one only. So this one, occupies 8 electrons, but we have 6 here. So let's see how it's going to be. 1, 2, 3, 4, 5, 6. Okay, 6, right? So meaning that it needs 2 more for it to be full. All right, so it needs 2 more for it to be full. Are we together? So I said that oxygen atom requires 2 electrons for it to be full. So mean that when we add 2, it will be what? It will be 8. Okay, so this is how you find the structure of oxygen, or of an atom. This is the electronic configuration. This is the structure of this element, oxygen. But we are not looking at this. Okay, we are looking at chemical formula. If you are new to this YouTube channel, kindly subscribe and share the link to your friends so that we may benefit as a huge number, not a smaller number. So it needs what? 2 electrons for it to be what? To be stable. All right, it needs 2 electrons for it to be stable. I said that non-metals receive, okay, or gain, or share electrons. Are we together? They receive, gain, or share electrons. So meaning that it needs to receive this atom. This is a non-metal here. It is on the non-metals like this. So it is on the non-metals. So meaning that it needs to gain or receive how many? 2 electrons for it to be what? To be 8. So this is how you check. Okay, but there is a shortest method that I'll teach you for you to know how these atoms on the periodic table gain and receive electrons. How many so these 2 which it's supposed to gain for it to be stable. So these 2 which is supposed to gain for it to be stable, it is what we call a valence number. Are we together? It needs 2 electrons. electrons to be stable, like this, to be stable. I'm breaking it down so that you be able to understand. If you miss this, you can't pass. Okay, if you miss this, then you can't pass. So you need to have this as you will be writing your exam, as you will be doing these other topics which are ahead. You need this because it will be asking you about this. Make a chemical formula, what is the valence number, so for it to be stable it needs 2, and this 2 is called the number that it needs. It is called the valence number. Okay, the valence number. Okay, so what about, let's check, what about a metal? Okay, what about a metal? So let's take a metal. Let's take what? A metal. Another metal. What metal can we use on the periodic table? So these are the metals. These are the metals. Okay, so what metals can we take? Okay, let's take magnesium. We want to see its valence number. Okay, want to see its valence number. The valence number, the number that it gives, since metals gives electrons, but this one we see receive. So want to see what this metal give, how many electrons this metal give. Okay, so we said magnesium. So magnesium, like this, magnesium, so its symbol is Mg. You need to know the symbol. Okay, you need to know the symbol. It has 24 as the mass number and 12 as the what? The proton number. And this proton number is equal to the what? To the electron number of an atom. So here, this is the K energy level, L energy level, N, M, and N. So I said that the first shell always occupies only two electrons. So when you subtract 2 from this one, when you subtract 2 from 12, it is what? 10. Okay, so mean that there are 10 electrons left here, since we've gotten 2 from it. So there are 10 electrons left from this metal. Okay, there are 10 electrons left. So we said that these others occupy only 8 electrons. The maximum of what? 8 electrons. Okay, so the maximum is what? 8 electrons. They don't occupy more than 8. So when you subtract 8 from 10, since we had 12, okay, we had 12. When subtract 2 from this one, we have what? We have 10. So these two, it's here. Okay, so we said that this one occupies 8 electrons. Let's subtract 8 from this one. 8 minus 8 is equal to what? Is 2. Is equal to 2. So this 8 here, we'll put it here. Okay, this one, because it occupies 8, so mean that it is full. So where is this 2 going to? Where is this 2 going to? So this 2, it will be what? To be where? Here, like this. Okay, like this. All right, so meaning that this atom is a metal. It gives, I said metals give or lose electrons for them to be what? To be stable. That is the reason why they give electrons. They are supposed to be stable. You know, when you are stable, something that is stable, it can't be broken. Okay, something that is stable, it cannot be easily broken. So they need to be stable. Okay, like we always wish to be stable in life. When someone is stable in life, you know, you'll be doing well and you can't even complain. They don't complain very much like those who are not stable. That's how it is. So that's how it is with metals and non-metals, or should I say elements. So this one, it needs to give, I said metals give or lose electrons. So mean that it's supposed to give 2 electrons to a non-metal. The metals don't give to metals, they give to non-metals, meaning that any metal that wants 2 electrons, this magnesium will be able to give it. Okay, when it reacts with it, it will be able to what? To give. So this metal, it gives 2 electrons, and this is what we call the valence number. The valency number. Okay, meaning that magnesium has a valence number of 2, like that. All right, magnesium has a valence number of 2, like that. So that's how you know the valence number. So I want to show you how these valence numbers are on the periodic table. Okay, so these valence numbers, they are arranged according to the group. Okay, according to the group. You know that these going this side, they are groups, and coming this side, they are periods. So this is group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. Then starting from this side, you learned that this is the period 1, period 2, period 3, period 4, 5, 6, 7, going on. Okay, so that is how it is. So here, these atoms of elements, I'll do it first. These atoms of element, they are arranged according to their groups. The valence numbers are arranged according to their group. So mean that these ones in group 1, this is group 1, they have the valence number of 1. You should know this. You should know this. Make sure you just know it by heart, that those who are in group 1, they have 1 valence number, meaning that these are metals, they give only one electron. So these ones which are in group 2, they give 2 electrons. You should know it. So this is where we got magnesium, and we actually found that it is 2. So they give only 2 electrons. So these ones on group 3, they give 3 electrons, like that. They give what? 3 electrons, like that. So these on group 4, there is what? There is 4. Okay, 4. So here there is a mixture of metals and non-metals. So these are the non-metals. These two, they are non-metals. So these ones, these two, they receive 4 electrons. Okay, they receive 4 electrons. Then these ones, they give 4 electrons. Same applies here. Here they receive 3. This one receives 3 electrons, but these ones give 3 electrons, like that. So here again, when you reach number 4 here, you start from here counting again. So you start counting 1. Okay, 1. So mean that these ones, they receive, these are non-metals, they receive 1 electron. These ones, they receive 2 electrons. So this is where we found oxygen. This one, they receive 2 electrons. So this one, they receive 3. Okay, so how do you know it? So you start group 1 to group 4. So group 1 to group 4, it is just according to the group. So 1, 2, 3, 4. Mean that their valence numbers is what? Is 4. Is 1, 2, 3, 4. Okay? Then you start from here, group 8, group 7. So 1, 2, 3, like that. So you should master this. You should master this. It won't be indicated on the periodic table. But whenever you reach an exam room, do the same. Okay, do the same. You number them like that. So mean that these ones receive 1, these ones. So the valence numbers is like that. Okay, so that's how it is. All right, that is how it is. Okay, that is how it is. So you need to know this, please. You need to know this. Then this here, they give 1. This here, they give 1, but they do specify that you find that the question is telling you iron 2, chromium 2, iron 3, cobalt 4, shan. That's how it is. Okay, That is how it is. So for these ones, they will specify, but if they don't specify, just know that they are giving only one electron. These are what we call transition metals. These are transition. Is it like this? Is it like this? Transition metals. Okay, transition metals like that. So they only have one as their valence number. These ones 1 2 3 4 3 2 1, like that. Okay, like that. So this is how it is. Okay, so if you are new to this YouTube channel, kindly subscribe and share the link so that others may benefit as well. So you should know this number as you are doing your revisions. Number as you are watching this video, make sure that you number your periodic table, the periodic table that you have. You number them and know that these are their valence numbers, meaning the number of electrons that atoms of elements lose, gain, or share among themselves in order to attain or to be stable, to attain the stable structure, or to be stable. Okay, to be stable. Are we together? So if you are new to this YouTube channel, kindly subscribe and share, and remember to like and comment. Okay, so if you have any question, you can ask me. This is my WhatsApp line. If you need tuitions, online tuitions, this is my WhatsApp line. You can contact me on this app line so that we talk. Okay, so in the next video, I'm going to do with the chemical formula so that we know what a chemical formula is, so that we know how to be